Assalamualaikum warahmatullahi wabarakatuh. My name is Hidri, and today I will be presenting about my project which is titled Solar Energy Measurement using Arduino under the supervision of Dr. KYAIRUL AZMI in BAHARIN. So for the introduction, nowadays people around the world tend to use the renewable energy. This is because the increasing of global warming of fossil fuel. These projects have to measure the important parameters on PV module to help grow the demand of green energy. Next, for the problem segment, we found that the ordinary multimeter also could measure the parameter of PV module, but the data readings of ordinary multimeter are instantaneous values. It cannot be kept for lengthy periods of time or a set time frame. Moreover, the data loggers for this meter are usually expensive, so the idea to create a low-cost yet dependable project that can measure while storing the data is crucial. Next, for the project breakdown, we want to create a circuit or device that could measure the parameters and display it on LCD. It must measure the three essential parameters, which is voltage, current, and temperature. Next, we will use microcontroller Arduino because it low cost and precise measurement. Next, for the objective, we want to be able to simulate the circuit and build the Arduino codings based on project's aim. Next, we want to be able to measure all the parameters needed and implement the hardware circuit based on project simulation. For the scope of the project, we said that parameters measurement is continuously recorded within time, which is every 15 seconds for 10 minutes. The coding must be designed and compiled for the circuit to project to work as intended. Then we will compare an accelerometer with this meter to calculate its error. So this is our list of hardware. We use all of these items to create our circuit hardware. Next, for the list of software, we use PLX-DAC to record and store the data in Excel. For purchase, we use it to simulate our circuit, and Arduino for the microcontroller Arduino coding. So this is our circuit of the project. As you can see here, they are our temperature sensor and current sensor. For the voltage, we use the voltage divider, which is connected to the microcontroller Arduino. Then the display will be displayed at the LCD. So this is my flowchart of the project. This pictures that our project from the start until the end. So for the hardware flowchart, this is my progress during the project assessment. So for the hardware test, we test it on two conditions, which is 9V battery and 5V solar panel. So for the 9V battery, it displays a certifiable value with only a small percentage of error on reading. But for the 5V solar panel test, the result is impaired with the desired result, especially on voltage, because it's supposedly to display around 4 to 5V. This is maybe because of the irradiance brought by the solar panel is not enough to power up the circuit. So after we test it on the other two conditions, we will connect it to the 30 watt solar panel. Here we use a buck converter to step down the input voltage to 2:1 ratio. This is to conserve the hardware circuit from being overloaded. This is my demo of hardware.
So here is my setup hardware for this project. Here we have the PV module connected to the circuit hardware. For the PV module, we use a 30 watt PV module with a 18 volt voltage, as our circuit could only support up to 20 volt only. For the circuit hardware, the safety cover has been made to maximize the safety during test. Next, when we connect the PV to the circuit, the parameters of the PV is calculated, such as voltage, current, and temperature. Then we connected our circuit hardware to our laptop to read and record the data measured by the circuit hardware. For this part, we use PLX software to record the parameter, as it is a convenient way to record it as it link the data to Excel. For this project, the data is recorded for every 15 seconds for 10 minutes. We recorded our data under two conditions, which is sunny day and cloudy.
So next, for our voltage parameter data. This is our voltage parameter data, which we measure on two conditions, which is sunny day and cloudy day. This is our temperature parameter data. As you can see here, there's not much difference for the temperature value between these two conditions. And next, for our current parameter data, the parameter data is basically the same under these two conditions. So for the measurement and comparable, we compare the new meter to a reference meter. So this is our error recorded. As you can see here, the error from the current is too high because of its sensitivity of the current sensor. So for discussion, this parameter must be measured under direct sunlight, because if we test it under a UV lamp, it cannot get the irradiance from the sunlight, so the circuit will not detect it. So another discussion, we encounter some problems on current sensor. As we stated earlier, the percentage error is high. This is because we use a 30 amps current sensor, so the sensitivity of the sensor will decrease. Next, for the conclusion, the project objective were fulfilled, including measuring solar panel parameters. This project also successfully documented the ideal location and timing for the solar energy. On average, the greatest voltage value recorded is 8.46 volt on sunny days and 7.66 on cloudy days. So this is my recommendation. This project will surely bring ease to the user, as it convenient and at some cheaper price. It also will serve as a springboard for future solar energy measurement application. It also has a wide range of application because it can support until 30 watt solar panel. So this is my reference for this project. So that's all for me. Thank you.